Within this chapter, we go more into depth on what SQL commands and statements can do for us. Remember, we must build our SQL skills to have MySQL or MySQL Workbench work best for us. Here, we have a summary of the topics we will focus on in this chapter. Again, the more commands you can use in statements, the more you can do and the more results you can produce when querying. In SQL, our null value is considered to be an unknown or a maybe, whereas in Access, it just gives us an empty field. Remember, from Excel functions and requires both to be true, and or only requires one of the two to be true overall. You can always check for null values using the is or is not commands. Like in programming, where we can have nested functions, SQL allows us to create nested queries, i.e., a query within a query. Here we are doing one query or the other query. If the first query produces data input, we stop. This is how we structure a nested query using SQL statements. You'll notice query in query. Here we have less commonly used commands we can use within nested function. All is most common here, likely why the code features it. All. Like any file, we create an alias to avoid any issues associated with the loss, in this case, of data. The syntax of our SQL statements can be changed based on what commands we are using for our query. The exists command is commonly used in a similar fashion to null to see if data is there. It's common in checking for a populated database. The unique command assists in addressing redundancy issues you may have within your table. Here, and here, you can see exists and does not exist or not exists within SQL statements and explanations on what these statements do. Here, we use the distinct and as commands we saw in Chapter 6. Join, in some ways, is similar to union, where we're combining data. While join command is commonly used, there are a few different types of the join functions. Here, we see how natural join works in both description and SQL statements. Here, we describe how inner, left outer, and right outer joins work. Here is a visual of SQL statements for our left outer join. Notice how, like in programming, sometimes syntax can be written differently, but do the same thing. Full outer join combines your result for both your outer joins, left and right. Notice multiple join commands in this statement. In Microsoft Access, you may have seen aggregate functions when creating a query and using the totals row. We can do the same in SQL. Your query can also rename attributes using the aggregate functions. In theory, you should not have a null value with aggregate functions, so they are discarded. There are aggregate functions which have the sole purpose of returning a true or false result. These are known as booleans. Again, you should be familiar with group by and count from the totals row in Microsoft Access. Here, the SQL statements show how count and group by would be used in a statement. Having allows us to restrict our results. Notice the correct syntax here compared to the next slide. Like when programming have incorrect syntax, there can be errors. We try to avoid all errors if possible. Here, we create a nested query to accomplish our task from the previous slide. With command is used when we need our query to look visually appealing, which is rarely needed. From a syntax standpoint here is how you would use the with command. Consider case to be like an if statement in programming. Here is example syntax where we use the case command. In this slide and in this slide, just like programming languages, SQL allows us to use recursion, but it is related to SQL for our query, as you see with their SQL statements. Here, we use group by, having, and order by all at once to explain syntactically how they work. An assertion is similar to an assumption, and a trigger is again similar to an if statement. If something happens, do this. Here is an example of how we can use the create assertion command in SQL. Again, think of a trigger in terms of an if function for programming, where nothing happens unless a condition is met. Here is standard syntax on how to find out if a condition is met using a trigger. Here, if a new hire is greater than a certain employee, salary-wise that is, the supervisor is alerted of this violation. Think back to Microsoft Access with datasheet design and SQL view options. In SQL, or SQL, a view shows us our information in the current state based on the data within our schema or database. View command can be considered similar to a query, considering they both provide us with data as output. Keep in mind the database management system keeps everything up to date with respect to view. You can also remove or clear a view using the drop view command. View should be used only when needed due to the complexity associated with queries. A bigger query result requires more computer cycling time with a view. We could create one view at a time to avoid issues with large queries. These updates should be used based on your needs. If you do not need view updates often, use lazy. Or if you want an update at set intervals, use periodic. If total sal was not a computed value, we could update our view as necessary, as we try to do here. We can view more than just data. We can view joins and authorizations too. A database administrator, or DBA, is generally the one to make changes to a database at a company or university. In other instances, many individuals may have access or authorization to edit a database. If you want to completely remove all associated info with your database, use the drop command. We use alter to change settings about our schema as opposed to update. We can also modify constraints using the alter command. Cascade drops a column from view. Restrict prevents you from seeing it. They sound similar, but are executed differently. In this slide and our next slide, we have a table summarizing the SQL commands we've learned within this chapter. You should now have a firmer grasp on these concepts related to SQL.